بسم الله الرحمن الرحيم الصلاة والسلام على أشرف المرسلين. On va se rencontrer cet après-midi pour participer à la promotion d'un travail qui a été mené par la doctorante Talbi Sara sous la direction du docteur Rezolil Zad de l'université de Tébessa, assisté par son co-directeur Faizaï Soufiane, aussi de l'université de Tébessa. Donc, devant un jury composé essentiellement par le professeur, notre éminent professeur Haddad Mohamed Sherif de l'université l'Arbi Ben Mehdi Oumoulbouaghi, et aussi de l'examinateur local, professeur Razri Youssef de l'université 8 mai 1945 de Guelma, et du docteur Sharaitia Mohamed aussi du département d'architecture de l'université 8 mai 1945 de Guelma. Ce jury sera présidé par moi-même, professeur Kamal Jamal du département d'architecture de l'université 8 mai 1945 de Guelma. Donc, ce travail a été mené pour l'obtention du diplôme de doctorat LMD en architecture. Donc, il était intitulé initialement par le verbe anglo-saxon Urban Resilience as Vector for Sustainability Environmental Regulation Case of Tébessa City, ce qui serait l'équivalence de résilience urbaine comme vecteur de régulation environnementale durable de cas de la ville de Tébessa. Donc ce travail a été mené dans le cadre de la formation doctorale qui était initiée à l'université de Guelma dans le département d'architecture Paris-May par le laboratoire de génie civil et d'hydraulique de l'université de Guelma. Donc ceci donne le droit à la doctorante de présenter son travail publiquement après avoir pu publier un article dans une revue de renommée établie catégorie B. Donc ceci lui donne le droit de présenter son travail après avoir semé un ensemble de points qui dépasse 180 points selon la réglementation en rigueur dans la formation doctorale. Donc sans tarder, je vais donner la parole à Madame Talbi Sara en tant qu'impétrante de nous présenter l'essentiel de son sujet, et après cette présentation, la présentation sera suivie par une lecture scientifique sous un autre angle par les différents membres de jury, après une plaidoirie qui sera présentée par le directeur de thèse et son co-directeur. Donc à vous la parole, Madame Santardi.
So today I'm going to present my graduation thesis, but first I would like to warmly and sincerely thank the esteemed member of evaluation committee for taking the time to evaluate my research. So this research is under the title of Urban Resilience as a Vector for Sustainable Environmental Regulation. The case of study is Tébessa City. So, as we know, in each research, we start with the general background and problematic. As we know, our planet is facing many dangers in this recent decade, and caused by the changing climates. And the flood risk have one of these hazards that are facing our cities. And the concept of urban resilience has emerged a new concept to protect our cities and face these challenges. And Tébessa City, as all the Algerian cities, has faced significant risk, and the flood is one of these risks, because Tébessa City ranks the first place as the first wilaya that building, we have a number of buildings situated in flood prone, such as, or according to the National Economic and Social Council, which has been identified as a major natural hazard threatening this city. And And despite all the efforts by the government or the Algerian government, such as the ORSEC and the plan of protecting, our city is still suffering from this hazard and is not enough to protect our cities. And we can see that in the new poles in Tbilisi city that are created by the new decree of these new poles. As you can see here, we have some pictures that are taken from the Protection Civil Directorate that showing the degree of floods that are facing Tbilisi city. And here we can see the new pole of l'ADL, which are faced or recorded big losses, human and material losses. So the question, or our question in this research, is how can enhance the urban resilience in Tbilisi city against flood risk through the urban design? And to what extent can urban design, with its multiple parameters, contribute to enhance urban resilience and improving environmental performance in the city of Tbilisi in the face of flood risk? To answer these two questions, we proposed two assumptions. The first one is through we can enhance the urban resilience through the environmental conditions, and the second assumption is through the spatial morphology of the urban fabric. To explain more, the first assumption is to the participation promotes not only the production of sustainable development factors, but also the improved urban design through environmental parameters, only wells, precipitation, etc., according to the flood sustainability mapping of the city. The second assumption is contribute the cities and adaptive urban design focused on spatial morphology, such as streets, buildings, plots, etc., to anticipate and mitigate flood risk and reducing losses. So our objective in this research is focused on three following points, or three following levels. The first level is the environmental level, which analyzes flooding and its impact to develop or by developing flood sustainability maps using precipitation prediction to estimate the water level according to the Wadi crossing Tbilisi city. And the second level, which is the urban, enhanced urban design by identifying key parameters and assessing urban resilience. The third objective is the architectural level, find a contribution and reflection on how to adapt and reduce flood risk and losses in order to ensure the ecological comfort of construction. So our thesis structure is stand on three main parts. The first part, of course, is the theoretical support, which is the state of art, talking about the resilience, the flood risk, and the urban resilience. The second part is talk about the analytical part and assessment, is divided into two parts. And the last part is the global or the general conclusion of our research. So we start with theoretical support, which is defined the flood risk or flood hazard according to the Department of Environmental Protection, which is defined the flood risk as a physical state or a phenomenon that has the risk causing death, injuring, and recording human and material losses. And if we talk about the urban resilience, according to the Albert, is the city's capacity to adapt to change, build and buildings, and rebuild after any shocks. After the state of art, we found many methods that treated the resilience, the urban resilience against flood risk. We have the statistic methods, and that use tools like exploration, factors, analysis, and etc. We have the modeling method, which is utilizing the GIS and simulation tools, and the analysis method, and finally the multi-criteria decision maker. After that, we found, or we conclude, the theoretical support by three levels, which are the legislative level, which critique the legislative framework or text that can be a key regulation, include executive decrees and laws. The second level is the talk about the urban design, which is examining cities planning and focus on the parameter like plots and city and drainage system, etc. The third level is the natural level, which is stand on the studies environmental factors such as the soil, precipitation, etc. According to this, we took the urban design level as a topic that talking about that we can enhance or optimize the urban resilience through this level, which are stand in three parameters, which is buildings, street, and plots. And we can change this, or the variation of these parameters can change or variable by the five characteristics, which are modularity, redundancy, diversity, connectivity, and the efficiency. According to this, the multi-scale interaction we took, or in the analytic part, we find that we should touch the urban environmental, which talk about the historical fluid data, and the second part is the ecological climatology, which search about the relation with the weather and our wages of the level, the hydrographic networks. And the third one is the built environment, which talks about the land use change over the time. According to the last parameters, we have building and street and plots, that this involves scenario-based interaction focusing on these three parameters. And we found some, we changed in many scenarios to take the optimal one. The fourth part is the practical support, which is, or just to remind on the methods and tools. The first one in the urban environmental, we took or we use as a tool the remote sensing and machine learning and the GIS to find the fluid visibility mapping and to predict which the prone or the fluid prone that are exposed to this phenomenon. The second, the ecological climatology, we use remote sensing and machine learning also and GIS to see what the relationship between the precipitation and the water level in the wedges that crossing the urban perimeter of the city of Tbilisi. The third part, or analytical part, is the built environmental, which we use the remote sensing and GIS to find the spatio-temporal distribution of flooding land use plans, or to see how the impact of buildings on the phenomenon of the flood phenomenon. The last one is the flooding assessment, which we use the parametric approach to assess how can our parameters that we are choosing to enhance the urban resilience in this city. Of course, we passed with on the study context. Our study context, as we said in the title, is Tbilisi city. As we know, Tbilisi city is located in the extreme east of Algeria. And the urban, as we can see in the master plan development of Tbilisi, we can see in a red line is the urban perimeter of Tbilisi, and in a purple line we can find the hydrographic or the wedges that crossing the urban perimeter of the city, which are named like Wad Al-Anbas, Wad Sigi, Rafana, Wad Nagas, Wad Zarour, Wad Gnadr Sud, and Wad Shabrouk. And as we talked in the first, we took only a part to assess or to apply how we can enhance the urban resilience in Tbilisi city, just to see, this is a new poll, which name is 9A, to see how we can enhance this, the urban resilience through the urban design. So in the practical part, we start with the flooding analysis. Of course, this is the illustrator of the methodological flow chart. We start with the flood factors we extracted by the last research of Dr. Ali Hajla, that he extracted the hydrographic factor, topographic, climatic factor, and the human, just to see or as a database for geospatial. After that, we used machine learning with the help of 3 algorithms, such as XGBoost and random forest and nearest neighborhood, to extract the flood stability mapping of Tbisa city. Of course, we start this analytic by the recording or the information that we taken from a protection civil, to see where, as you can see in red, is the intensive flooding and remarkable geographical extent, and we search with using or in parallel with remote sensing to take some pictures to see in blue task the flooding that happened at that time in 2018 and 2022. And according to the factor floodings, we extract using the GIS and the remote sensing to extract these maps to help us to find, with the machine learning, these 3 results. According, each one is a result of one of algorithms. The A map is the algorithm of XGBoost, the B is the random forest, and the C is the nearest neighborhood model. The second part of analytical, we touch the ecological climatology, which start with the weather database or data collection, and we use the machine learning also with 3 algorithms. Why? Because the accuracy of these algorithms is a high value. It's given us a high value. So we predict with using the machine learning to see in the precipitation and the number of water level in Tbisa city into 2035. And here it is the maps. Here we have the minimum precipitation. We can see in the water level how can the settlement be, and the second map is in the maximum water level. The third part, of course, in the analytical part, which is the built environment, which is start with satellite images, which is use the remote sensing and the GIS to extract the land use change map and analyzing them. So the first step, we took the period from 1919 to 2023. So we have 4 maps. We can see in the red point that as the building index. After that, we can see the land use change maps between this the same period. The second map shows the spatiotemporal evolution of building classes over the period. And the last one is the spatiotemporal distribution of flood land use plans in the city of Tbisa over different periods. The last one, we collaborate the different maps in one maps as a result to see how can or the degree of impact the floods on the urban index. And here we can see the flooding assessment. So the flooding assessment, we use the parameter approach, which is stand on 3 parameters, which are the buildings, plots, and streets. This urban design, we change in each scenario the multiple layouts, and we testing them in Grasshopper to see the degree of impact. Of course, we took only a part, which is the pole number 9A, to see how we can apply this, the urban design to enhance the urban resilience. As we said, the urban design parameters stand on building, plots, and street, and it's variable from the 5 characteristics, which is modularity, redundancy, diversity, efficiency, and connectivity. So if you took this, and according to the state of art of this shots, in such parameter, we have theoretical talk about how we can enhance in streets, and for example, in modularity, we have the street that it can help to enhance it, and in redundancy, we can see the plots and streets. In diversity also, we determine the building sustainable according to the block size, and the plot is determined by the plot size with respect to the roadway and the street also. And we can find in the efficiency is talk about the plots and streets. The last one, connectivity, is talk about the buildings and streets. So we apply this theoretical on the maps of land use plan, which is we took the catchment area to simulate the fluids on our land to see how can the fluids can affect our urban fabrics. And the second simulation, we took the fluid on development land according to the URBACO, because they did that as a plan, land use plan approved by the DRIAC of Tbilisi. And we start to simulate each parameter independent to another. For example, we can find the buildings, or the building in danger. It's marked by the red color. The plots also, we can see how the degree, the fluid degree in these plots, and the street is the same thing. So the variable of the next scenarios, it's talk about, for example, the modularity is talking about the division of a street. The redundancy is talk about the plot, redundancy plot according to a regular square grid. And on the level of street is talk about the local matchedness. If we talk about the diversity character, it stands by the building size according to the VFR, and the plot stand on the shape and size, and the street also stand on the street edge and the interface matrix. Also in the efficiency scenario and connectivity, we can see the variable that touch the streets, the connectivity, and the size. And here it is our results. In each scenario or in each result, we can find in the end of each map the degree of fluid impact designed by or show it in a graph that shows the degree of impact. For example, here in modularity in street, we can see the degree of impact and redundancy also in diversity scenario, and the efficiency and the connectivity. So after all of these scenarios, we took the optimal scenario to discuss on it. Here it is, we can find the degree is a high degree in the level of building and plots and street. So in the discussion part, we can see that the streets or the buildings, the size of buildings, it's help to reduce the impact. Also, the plots, it can be, they were deemed to be the best possibility to resilience urban architecture against the danger of floods by the dimension of these plots, and also the distribution of these plots. And the last one is the urban design in the streets that shows that the connectivity of these roads can help to reduce the flood impact. In the last, we conclude our research or thesis aimed to enhance urban resilience against flood risk hazard in Tbilisi city by developing design recommendation routes in a deep understanding of design principle and the integration of existing frameworks tolerated to locate extent. So we can see that the GIS can help us to find or to predict the flood prone in our cities, to detect which are the dangerous places, and the parametric modeling can help us to assess the urban resilience against flood risk, illustrating how urban design factors impact the urban fabric. And the simulation results can justify flood damage assessment and inform urban planning strategies for flood-prone area. And the last point is urban resilience can be evaluated using 5 system-level characteristics by the modularity, efficiency, connectivity, redundancy, and connectivity. This feature will studied independently and influencing the urban resilience of our city. And to answer the first question, that of course we find a practical answer, which is the environmental conditions alone cannot ensure urban resilience or fully prevent flood. Simulations show that floods are worsened by blocked waterways, waste and human alternation for natural water system like wedges rather than just heavy rainfall or precipitation. And comprehensive strategies addressing both environmental and human factors are essential for effective flood mitigation. And the second answer is the urban design plays a key role in reducing floods risk through its interaction with building, streets and plots. So if you talk about the difficulties, of course, in my research I found many difficulties, such as the absence of some information, especially in flooding data, and also I didn't find somebody who worked on this topic before. So I learned by myself the machine learning, the GIS modeling, and the simulation or the simulation approach. And if we talk about the research limitation, of course, we found regarding to the assessment of urban resilience through urban design parameters, it is worth noting that the 5 urban design patterns were addressed separately in this study, and their impact was not assessed in a connected manner. So we can, in the next research, we can find connectivity between these parameters. And if we talk about the development perspective, we can apply this research on other hazards such as earthquake and the fire, etc. And thank you for your attention.